Good day and welcome to another physics lesson. Today we'll be looking at the principle of triangle of forces. We'll be looking at what the triangle of forces means and how we can use that principle in solving for forces or indeed for vectors generally. Our objectives include to state the principle of triangle of forces, to be able to calculate forces acting on an object using the triangle of forces, and then to resolve vectors into their components. Let's start by looking at equilibrium of three non-parallel forces. In previous lessons, we already looked at the action of two forces on an object, and we also looked at what resultant force is and indeed what the equilibrium force is. We looked at how to find the resultant of two forces that act on an object. But in this case, we are looking at three non-parallel forces. Non-parallel means that their lines of action meet at a point. The three forces meet at a point. So, if the three forces act to keep an object in equilibrium, that means that the three forces act to keep an object in equilibrium. The object is stable. So, what then happens? Now, in the situation that we have on the screen now, go at the diagram, we have the circular object. It has a downward weight acting downwards. That's indicated with the downward arrow. It has a tension T1 acting diagonally to the right, and then it acts a tension T2 acting horizontally to the left. So those are three forces and they are acting to keep that object in equilibrium. So let us then see what happens. The scenario we have is one that can be solved using the triangle of forces. The triangle of forces is a principle that says that when three objects act, or when three forces act to keep an object in equilibrium, these three forces can be represented in both magnitude and direction by the three sides of a triangle taken in order. What this means is that if you have three non-parallel forces acting on an object, just as you have on your screen, you can use a triangle to represent those three forces. You can see on your screen that the vertical force, W, that's the weight of the object acting downwards, W, has been represented with a downward arrow of a triangle. That's the one represented with the W. You can also see the horizontal force T2, represented by the horizontal side of a triangle, and then we have the diagonal force T1. So that is what the principle of triangle says. That's how the principle of triangle works. So now that we have a triangle, we can easily then solve for each of the sides of a triangle using a general knowledge that we have on how to solve for sides of a triangle. You have to note, however, that this principle will only work when the three forces are keeping the object in equilibrium, when the three forces are in equilibrium. If the three forces are not in equilibrium, that means if there is a net force or a resultant force, as it were, on the object, then you cannot use the principle of triangle of forces to solve for these forces acting on the object. This principle is based on the premise that the forces acting on the object are in equilibrium. Now, also, you have to draw your triangle such that each side of the triangle is in the same direction and the same orientation as the force that you want to use that side to represent. So, if on your three forces acting on an object, you have a horizontal force pointing to the right, by the time you are drawing your triangle, that horizontal force must also be the horizontal side of your triangle. You cannot have a horizontal force and then use a vertical line to represent it in your triangle, or a diagonal line. So the same direction must be maintained for both the force itself and the side of the triangle you want to use that force to represent. Now, once you have done all of this, then it's easy to solve for each sides of this triangle or each force as it were. The principle to use is just the sine rule, or what we also call the Lamai's theorem. Now, please note that the Lamai's theorem is a mathematical principle that is used to solve for different sides of a triangle, and indeed the angles of a triangle. It applies only for triangles. Therefore, we can use this to solve for the unknown sides of this triangle. Let's look at a solved example. We have a mass of 2 grams that is supported by 2 strings P and Q. The mass of 2 grams, we have to find its weight because we are dealing with forces here. So we have to convert the mass to weight. Using our equation for weight, W equals mg, where g is the acceleration due to gravity. So the mass of 2 kilograms will become a weight of 20 Newton. That's why you see 20 Newton on your diagram for the object pointing downwards. Now that object is supported by 2 chords P and Q. And then each of these chords makes an angle of 30 degrees and 50 degrees respectively to the vertical. Now we are asked to calculate the tension in the 2 chords. So essentially we have 3 forces on that object. We have the weight, and then we have the tension in P, tension in Q. Those are 3 forces. We now want to calculate for P and Q. Those are the 2 tensions since we only know the weight. Now let's see how that can be solved. As I said earlier, you can represent those 3 forces with the 3 sides of a triangle taken in order. If you look at the triangle we have there, you find that the vertical weight, that's the weight of the object of 20 Newton that was acting downwards, is also the vertical side of this triangle. And then the force P that was acting diagonally to the left on the question itself is also acting in that same orientation on this triangle. And the same is for force Q. So now that we have done that, in the question we were told that the angle between the string P and the vertical was 30 degrees. Angle between P and vertical was 30 degrees. That's why we have the angle between P here and 20 Newton as 30 degrees here. Here, 20 Newton being our vertical. Angle between them is 30 degrees. And then we also had the angle between Q and the vertical as 50 degrees, and the same is replicated here. Now, to find P and Q, we use Lamai's theorem, as I said, which essentially is that A over sine capital A equals B over sine capital B equals C over sine capital C, when you use the A, B, and C to indicate the sides and the angles in your triangle. But since this triangle does not have A, B, and C, rather it has P, Q, the 2 forces that we are looking for, and then the 20 Newton force. So P, that is the one side that we are looking for. P divided by sine 50 degrees. Sine 50 degrees. 50 degrees is the angle opposite the side P. So all the angles theta's here must be the angles opposite the side. Take note, the angle opposite the side. If you look at the triangle very well, you see that the angle opposite side P is 50 degrees. The angle opposite side Q is 30 degrees. And the angle opposite side 20 Newton will, in essence, be 100 degrees. Since total angles in a triangle is 180 degrees, and we already have 50 plus 30 giving us 80. So that means that C will be 100 degrees. So you take note that the angles we are using for each side are the angles opposite that side. Take note, that is the theorem. That's what Lamai's theorem says. So if we are able to do that, we have P over sine 50 degrees equals Q over sine 30 degrees equals 20 over sine 100 degrees. Now, having done that, these 3 sides of the equation can be used to solve for whichever we are looking for using any 2 of the sides. So we have one side that is known. We have 20 Newton and then we have sine 100. That one is known. We can use that one to solve for the unknowns. So what I did here was just to solve for Q first. So that means I have Q over sine 30 degrees equals 20 over sine 100 degrees. If I make use of my formula, Q will give me 20 sine 30 divided by sine 100, and that's how I got 10.15 Newton. To solve for P also, I just split the P side of the equation with the 20 Newton side that we knew, and then we have P over sine 50 degree equals 20 over sine 100 degree. Solving for P, like we did for Q, will give us 15.56 newtons. Let's look at another solved example. Here we have a body of mass 10 kilogram, meaning that its weight is 100 newton. This body is kept in equilibrium by two strings, two ropes. One of the ropes is horizontal, that's T1. And then we have another one that is slanting, T2. And that T2 has an angle of 40 degrees with the vertical. Take note, angle of 40 degrees with the vertical. So we can represent these three forces with a triangle. On the triangle, you can see that your vertical force of 100 Newton is also the vertical side of that triangle. Your horizontal side, T1, is also the horizontal side of the triangle. And then your diagonal side, T2, is the diagonal side of the triangle. Now, the angle between the diagonal and the vertical is 40 degrees. That's where we put the 40 degree here. Now, how did we get 50 degrees? It's just by simply applying this principle of the sum of angles in a triangle. All the angles in a triangle should give us 180 degrees. And we already know that one is 90 degrees because between T1 and 100 Newton is 90 degrees. And then we have 40 degrees. That's 90 plus 40, that is 130 degrees. So the balance that will give us a 180 degrees is the 50 degree that we have at B. So that's how the triangle was drawn. Now let us look at the solution to this. The solution to this, like I said, is by applying the sine's rule, or something also called Lamai's theorem. If you look at the triangle again, the angle opposite the side of 100 Newton is 50 degrees. So we have 100 over sine 50 degree equals T1 over sine 40 degree. If you make T1 subject of that, you will get your T1 to be 100 sine 40 degree over sine 50 degree. That will give you 83.91 Newton. Now for T2, the same thing is done. 100 over sine 50 degree equals T2 over sine 90 degree. Making T2 the subject of the formula gives you 100 sine 90 divided by sine 50. That will give you 130.54 newtons. So that's the force. Those are the forces in the springs, in the ropes, T1 and T2. Now, take note also that because the question we just finished, this question, the triangle we had there was essentially a right-angled triangle. So if you do not want to use Lamai's theorem for a right-angled triangle, you could also just use your regular SOHCAHTOA, which will work for a right-angled triangle. But take note that right-angled triangle only works, SOHCAHTOA only works for right-angled triangles. So if the triangle you draw is not a right-angled triangle, the only principle you can use is the Lamai's theorem or the sine rule. Do not use SOHCAHTOA for a triangle that is not a right-angled triangle. So you can attempt solving that same question using your SOHCAHTOA. You should get the same answer. So try it and see if you get the same answer. Now let's look at how to resolve vectors into components. How to resolve vectors into components. Now, whenever you have a diagonal vector, that diagonal vector has two components. It has the horizontal component and the vertical component. What do we call component? The component of a vector in a given direction is the effective value of that vector in that direction. So if you have a vector that is inclined at angle theta to the horizontal direction, how do we then find the horizontal component? That is given by Vx. X here, that subscript x, is used to represent horizontal. If you are familiar with your Cartesian coordinates, you know that your x-axis is the horizontal axis. So that is where we got these notations from. So V subscript x stands for the horizontal component, which is the x-axis. That will give us V cos theta. And then a vertical component, which is your y-axis, is Vy, and that is V sine theta, where in this case, V is the inclined vector, the one that is inclined at angle theta to the horizontal. So, take note, in essence, Vy and Vx will be at right angles to each other, because you have the V inclined, then Vy will be the vertical, and Vx is the horizontal. So both the vertical and horizontal components are at right angles to each other. Let's look at an example with to this respect. Resolve a force of 100 Newton inclined at 50 degrees to the horizontal into the horizontal and vertical components. So you have a force of 100 Newton that is inclined at 50 degrees to the horizontal. Then that means that our horizontal components will give us F cos theta. That's 100 cos 50. And then we get our answer. For the vertical component, that one is Fy, and it will give us F sine theta. That will also give us 76.60 newtons. Take note that for these calculations to work this way, the angle between the vector and the horizontal must be theta. Theta must not be between the vector and the vertical. So if the angle you have is the vertical, like this diagram you have, now we have two angles. We have angle alpha and angle theta. Theta is the angle to the vertical. If what you were given in the question was angle alpha, you cannot use this equation as I have used it, because angle alpha is not an angle to the horizontal. Rather, it is an angle to the vertical. So you must first of all find the angle to the horizontal. And since you know that theta plus alpha will give you 90 degrees, so if you are given alpha, all you need to do is to subtract alpha from 90 degrees and you will get your theta. It is only then that you can now go on to find the horizontal component and the vertical component. Please take note of this. In many questions, you will be deliberately given the alpha, and students will not be careful enough to see that what they have is the alpha, is the vertical angle. You have to take note of that. You can only use this with the horizontal angle. So you must first of all ensure that the angle you are working with is the angle to the horizontal for the vector. Take note. So with this, we have come to the end of this lesson. We have homeworks here. So go through the notes, the video again, listen to it, and then attempt these questions that we have on your slide. If you do have any questions or comments, please do not hesitate to drop it below on this page, and you will get a response from me. Now, also feel free to check on other videos on the YouTube page. That's David Oluwadara. That's the YouTube name, David Oluwadara. There are videos on different topics there that you may find useful for your studies. That's it for today. All the best.